So permutations. Determining the number of ways that n elements can be arranged in order is an important application of fundamental counting principle. You don't need to write that down. You need to write down all the rest of it. A permutation, an ordering of n elements. Elements are just things. Okay. One element is first. One element is second. One element is third. Order matters. Guys, listen to me. Order matters. Got it? Okay. So, big red letters. Number of permutations. The formula is as follows. N times n minus 1 and so on, which just means n what? What is that?
N factorial.
N factorial. We just went over the problem where you had 6 people in a car, right? Okay. Now, technically, order doesn't matter with 6 people in a car, but once you put the first one in the car, can you get another one? Can you get a different one?
Yeah.
I mean, can that person sit in 2 seats?
No.
No. Okay. So when you had the one of the girls and boys walking out the door, right? The girls and boys walking out the door, do you get that problem? Is somebody going to be first? Is somebody going to be second? Is somebody going to be third?
Yeah.
Okay. Give me another thing where you order matters. What about a combination to a locker? Does it order matter?
Yes.
Yeah. What else?
In the drive-through. Yeah.
In the drive-thru.
You can't mix up the.
Okay. So a permutation is where order matters. We will have another formula for it as well. We'll go through things and we'll show how this one relates to that one. So you got n factorial for when order matters. Got it?
No.
What else are you writing?
Can't tell you.
Writing
Write
on the
bottom
at the same
part?
time.
In the box? Yeah.
Just says if order matters. I mean, that's all it's saying. It's saying order matters like 6 different ways. Okay, this box is what is in the book. And that's why I put them in here so you can see the main things out of here is the formula and what?
Order matters.
Orders matters and they are,
Yay.
it's called a permutation. Okay? So you need to learn how to read textbooks and get out what's important. So that's why I always feel it's important to put those on there. But I would not ever write notes verbatim. Your hand will fall off. Okay. We good? Okay. How many permutations are possible of the letters A, B, C, D, E, F? Okay. So how many letters do I have? 6? Okay. So it would be 6 factorial, correct?
Yeah.
Because of the fact, I'm going to just show you why again. I have 6 spots, right? When I go to place the first letter, how many do I have to choose from?
Wait.
6. When I go to place the first letter, I have 6 letters to choose from, yes? And then what? How many do I have? 5. Alex, do you need to stand up?
No.
Okay, then I have what?
4.
4, 3, 2, 1. Take notes. Maybe that'll keep you awake. Okay, so, but remember with the permutation, order matters. So ABB and BAB are counted as different, right? Okay, if order didn't matter, just grouping, are those different? No. Okay, so you get the difference between the two. If I take 3 people and I put them in a group, in a math group, okay, wait, how many people do I have? 2, 4, 6, 8, 10, 12, okay? So you got 12 of you. I want groups of 3. How many groups can I have? 4. I have 4 different groups, right? Okay, but I have groups of 3, but in each group I'm going to assign somebody that's going to be like the recorder, and somebody's going to be the fact checker, and somebody's going to be, I don't know, the guesser. Okay, there's 3 different jobs. So in that one group of 3, how many different groups could I, like, how many different
9.
ways could I assign it? 3 times 2 times 1, so it'd be 6. And then how many groups total did I have?
3.
4. So I have 4 groups, and I could do 6 different ways in each group, so 24. Okay, so you get what I'm saying?
Yeah.
So the first one I only had 4 groups because the order didn't matter. But once I started assigning you a specific job, are you going to have more possibilities? Yes. Okay, am I good? Love how it goes back sometimes. Okay, counting a horse race. 8 horses are running a race. And how many different ways can these horses come to the first, second, and third? I think I should have done these yesterday. Sorry. You got it without it. Okay. This formula is kind of just intuitive because you only have so many, right? Okay, so I want first, second, third, yes? So first, second, third. How many horses can win first?
All of them.
8. After one's won first, 7,
6.
6. And I'm done. I stop.
You don't have to multiply that.
Well, I do, yes. But why don't I go on to 1? Why don't I go all the way down?
You get first, second, and third.
I only wanted first, second, and third. So 42 times 8 would be 6. 336. 336. Okay. So you were doing that already without me going through this, right? Because it's how can I place this? How can I place this? How can I place this? Permutations are just kind of something we do once you know the principle of it. Okay, now, this is different. This is, when we ordered 8 people, we went from 8 down to 1, so it was 8 factorial, correct? When we ordered the horses, we only picked how many? 3. So, this is permutation of R things out of the total. So R is how many you're picking out of N, the total number there are. So 8, choose 3. Make sense what I'm saying? So remember when we did the, well these are permutate, sorry, because what matters? Order. Okay, so permutations, order matters. So it's not, I shouldn't say choose. It's 8 permutate 3 because we had 3 horses because we didn't pick all 8. Make sense? So here's the formula. Well, first of all, N is the total number of things in the group. The total number of people in here are 12, well 13 if you count me, and I'm picking 3 of them. Get it? Okay, so N factorial over N minus R factorial. Don't worry about this. That's the breakdown of the formula and how it looks. That means nothing to you because that's not how you're going to use the formula, is it? So we just did this problem and we got 336, yes? So we better still get what? 336. So if I have, how many total horses do I have? 8. Permutate 3. And I know it's a permutation because what matters? Order. How do I know order matters from this problem? It says first, second, and third. It just doesn't say how many groups of 6 can I get, does it? So now, what's my N? N is 8, and R is 3. So fill in the formula. So I have 8 factorial over 8 minus 3 factorial.
Yeah, you 6.
So 8 factorial over 5 factorial. Now remember, 8 factorial is 8 times 7 times 6 times 5 factorial. Because we've reduced these before, yes?
Yeah.
Yep.
And these reduce, and I have 8 times 7 times 6, which is what? 336, what we just did. Make sense? I will tell you, I find myself not using the formula after I've done it a long time. When I have things inside, I just know it's going to be like 8 times 7 times 6. Now, if I have 28, choose 10, I'm not going to do that. I'm going to use the formula to do that. Okay? So when do I use this? When do I use permutations?
When there's
When they go in order.
When order matters. Because we're going to do combinations also, and you have already done the choose formula. It's the same formula that we've used before. So I will give it to you again, but it's the same formula. Okay. Distinguishable. What does distinguishable mean?
Noticeable? You can pick them out from others.
I can tell them apart, right? Okay. So suppose you have a set of n objects that has n sub 1 of one kind of object, n sub 2 is the second, n sub 3. So there's just different objects, okay? So there's 1, 2, 3, 4, 5 in them. The numbering of distinguishable permutations of an object is, okay, n factorial divided by, now this really doesn't make sense till you see it work. Okay, you got it? Like, reading this formula does not make a whole lot of sense to me, so that's why I'm reading it to you. This n factorial is the total number of things you have, okay? Now, this n sub 1 factorial is how many of the first things you have, how many of the second things you have, how many of the third things you have, okay? So, how many distinguishable ways can you order the letters in banana? How many letters in banana do I have? How many letters? Total.
Oh, I thought you meant like.
No, I get it. How many total? 6. So 6 factorial. How many B's do I have? 1. How many A's do I have?
2,
3.
3.
How many N's do I have? 2. So underneath here, I have 1 factorial for the B's. 2 factorial for the what? For the N's. And 3 factorial for the A's. Now, I could have put 3 factorial before 2 factorial. Does it make a difference? No. Okay? So then I reduce it. Now, that formula does not give you that, does it? So it's how many factorial of each thing you have. So 6 factorial is 6 times 5 times 4 times 3 factorial, correct? So 3 factorial reduce. 1 factorial is just 1. And 2 factorial is just 2. So you want to divide 6 or 4? Probably 4, right? So then I have 30 times 2 is 60. I can write them 60 distinguishable ways, okay? But if they weren't distinguishable, it would be 6 factorial, which is 720. See the difference between that? So the book likes to give you words, or they just give you a bunch of letters and then how many different distinguishable ways. Yes?
On the bottom, does it matter, like if you have 1 factorial, 2 factorial, 3 factorial?
No. You could have 3, 2, 1, 3, 1, 2. It's all multiplication, so it doesn't matter. I shouldn't have written them that way. I should have written them mixed up.
Wait, why'd you put 2 factorial? You crossed out the 4 for the 2?
Yeah, because 2 factorial is 2 times 1, so it's just 2. So 2 goes into 4 twice.
Wait, wouldn't you have just rolled out 5, 4, 3, 2, 1, and then crossed out the 3, 2, and the 1? And left the 4.
If I would have said 6, 5, 4, 3, 2, 1 over 1 times 2 times 1 times 3 times 2 times 1. That's 1 factorial, 2 factorial, 3 factorial. That's this right now. So this goes away, the ones don't mean anything, the 2, the 4 is 2.
Wait, okay, but the top one, the 3, 2, 1 isn't factored out, so could you have just left, I don't know what you did there, but just crossed out the 1, 2, 3 on the bottom and the 3,
No,
2, 1 on
this
the
is
top.
1 factorial, 2 factorial,
Isn't it the
3
same on the top?
No, the top is. Then I did 6 times 5 times 4 times 3 factorial.
But why do you stop at 3?
Because I have 3 factorial right here,
And you have 2 factorial.
and 1 is 1, and 2 factorial is 2 times 1. 2 factorial is 2 times 1. So the 3 factorials reduce. 1 times 2 is all just 2, and 2 goes into 4 twice.
So you do 6 times 5 times 2.
Yes. I don't care how you reduce it, your answer is what when you're done? 60. I would just honestly prefer you not to multiply it out. These are meant for no calculator. Would not give you a calculator on this problem. And if you go and multiply that all out, your brain's going to shut off and you're going to have a calculator, correct? Okay, combinations. We have discussed combinations and you really didn't know it. Combination is a method of selecting subjects in a large set, which order does not matter. It is not important. Permutations, order what? Matters. Combination, order doesn't. The biggest thing I get all the time is people say, well, a combination block, order matters. Yes, it does. That's just what they call it. A combination block came out after permutations and combinations were figured out. So, I don't know who named it. So, when order isn't important, ABC is the same as BAC. It's also the same as what? What's another way I could mix those up?
CAB.
CAB. Is there another way?
BCA.
ACB
BCA.
and BCA. And there should be one more.
CBA.
CBA? Okay, so permutations, I have how many choices? 6, yes, because order mattered. But combination, I have what? 1. Because order doesn't matter. It's the same thing when I grouped you guys in sets of 3.
Okay.
In sets of 3, I had 4 sets of 3, yes? But once I started breaking you up in 3 different things, order mattered, right? Okay, so then I had 12 choose 3, and I'd have to reduce all that out. So, are there going to be more combinations or more permutations?
More permutation.
There's going to be more permutations because that order matters.
Then how much do you need to write down?
I would write down this. And I would also write down maybe the fact that there are fewer combinations than permutations, right?
Fewer.
Combinations than permutations. And your example was there's 12 of you. I had 4 groups of 3, correct? But if I have permutation, so I have 12 permutate 3, so that would be 12 factorial over 9 factorial. So that would have been 12 times 11 times 10. So this is 131 times 10, so it's 131. Okay, I'm going to assign you 3 different jobs in those groups. I could have, because I have to start mixing all of you guys up, I could have 1,310 different groups. Because you could be 3 things in your group, but you could be 3 things in all the other 4 groups, but then you have to mix all of y'all up, right? So when order starts mattering, do I get a lot more choices to pick from?
Yes.
Yes. Okay, that formula is, oh, okay. Well, we're gonna write this one out, I guess. Okay, how many different ways can 3 letters be chosen from A, B, C, D, E? The order of these 3 letters is not important. So the first one is what?
A, B,
A, B, C. We're going to do this in some sort of an order. Got it? So then A,
B, E.
how about A, B, D? B, D. And then A, B, E.
That's gonna be a lot.
Okay? Not as many as if I did permutations, right?
Okay,
So then B, C, D. B, C. Oh, I should have gone A
yeah.
further. Oh, I can go across.
A,
B, C.
A, C,
Oh, you want to do the A? Go back to the A's. A, C, D.
A, C, B, A, C, E, A, C, B.
No. A, C, B is the same as A, B, C, correct? Because order doesn't matter.
Okay, so that's it.
So I can do A, D, E, and that's it for the A's, right? I think that's it for the A's. Okay, so then I have B, C, D, B, C,
E,
E,
B, C.
B, C. Now B, C, A. Have I done that already?
Yeah, A, C, B.
I have A, B, C, right? So that's done. Do I have a B, C, E?
No.
No. Okay. So then C, D, E. Can I do anything else with that? No. Because if I went to, well, I could do C. Could I do C, E?
B? No.
Oh, I could.
Yeah.
Could I have B? I could do B, D, E, couldn't I?
Yeah.
Yeah. Okay. So could I go C, E, A?
Yeah. No.
No?
You already have A. A, C, E.
Oh, I already have A, C. I was gonna cross out both. Okay, so then D, E, A.
Nope.
I don't have it, or I
We
do.
have A already
Yeah.
up there on top.
I know, but I'm trying to figure out why my pen stopped working. Okay, so DEA doesn't work because I already have that right here, right?
Yeah.
Okay, so how many do I have? I have 6, 7, 8, 9.
10.
10. So I have 10.